The dashboard shown in the video is a curated collection of embedded YouTube videos related to AI/ML, authored by Pradeep K. Suri, focusing on AI modeling, machine learning, and education. Here's how it could be interpreted in the context of a mentorship program in AI modeling. Key features of the dashboard. 1. Title. Embedded YouTube videos, Pradeep K. Suri, author, researcher, consultant, and AI/ML architect. This indicates that the content is educational and relevant for AI/ML learners and professionals. 2. Curated video topics. The videos cover diverse topics relevant to AI modeling, such as ISO 21001 in education, likely discussing AI's role in improving educational frameworks. AI-powered pie charts, representation of AI-driven decision-making using data visualization techniques. AI model, the formulas displayed, explanation of key AI mathematical models and formulas. Synopsis of AI/ML handbook, a structured overview of AI/ML concepts from a documented source. 3. Visual representation. The dashboard uses graph-based visualizations, which suggest an emphasis on data-driven AI learning. Topics such as decision trees, validation grids, and formula visualization indicate that the mentorship focuses on the technical depth of AI modeling. Relevance to an AI modeling mentorship program. 1. Structured learning path. The videos are to provide a structured learning curriculum for MENTs, covering AI/ML theory, data visualization, and applied AI models. 2. Data-driven AI understanding. The use of Sankey diagrams, pie charts, and validation grids suggests that the mentorship program includes AI model interpretation, mathematical formulation of ML models, visual data storytelling techniques. 3. Self-paced learning and expert guidance. Since these are embedded videos, MENTs can engage with pre-recorded expert insights, helping them understand complex AI topics at their own pace. 4. Industry-oriented training. The inclusion of ISO 21001 educational standards suggests a mentorship program that aligns with industry the best practices, making it suitable for AI professionals and researchers. Potential enhancements for mentorship. Additional AI case studies could be included in the dashboard. Interactive discussion forums linked to each topic can be integrated. Hands-on coding tutorials with guided examples on AI modeling. Detailed breakdown of the dashboard for an AI modeling mentorship program. The dashboard presents a structured approach to learning AI modeling through video-based mentorship. Below is a detailed breakdown of how this setup can be leveraged for an effective AI modeling mentorship program. 1. Purpose of the dashboard in the mentorship program. The dashboard serves as a central hub for MENTs, providing structured AI learning resources, video explanations on AI modeling techniques, industry-relevant AI/ML concepts, visualization-based AI decision-making insights. The videos likely cover practical and theoretical AI topics, helping MENTs gain a deep understanding of AI modeling. Detailed breakdown of the dashboard for an AI modeling mentorship program. The dashboard presents a structured approach to learning AI modeling through video-based mentorship. Below is a detailed breakdown of how this setup can be leveraged for an effective AI modeling mentorship program. 1. Purpose of the dashboard in the mentorship program. The dashboard serves as a central hub for MENTs, providing structured AI learning resources, video explanations on AI modeling techniques, industry-relevant AI/ML concepts, visualization-based AI decision-making insights. The videos likely cover practical and theoretical AI topics, helping MENTs gain a deep understanding of AI modeling. 2. Key learning modules in the mentorship program. Each embedded video corresponds to a specific AI learning module. Below is a structured mentorship path based on the video content. Module 1, AI in Education, ISO 21001. Video, ISO 21001 in Education, How AI Improves Learning. Objective, understanding how AI can enhance educational models and student performance. Mentorship activity. Discuss AI-driven educational tools. Analyze real-world case studies where AI models improved education outcomes. Implement AI-based trend forecasting for student performance. Module 2, AI-powered data visualization. Video, AI-powered pie chart, representing decision tree impact. Objective, using AI models for decision-making and data visualization. Mentorship activity. Learn how AI models use decision trees for prediction. Implement AI-powered pie charts to visualize decision impacts. Work on a real-world dataset to create AI-driven visualizations. Module 3, AI Model Formulations and Validation. Video, AI Model, the formulas displayed. Objective, deep dive into mathematical foundations of AI modeling. Mentorship activity. Understand key AI formulas, example regression, deep learning equations. Implement model validation techniques, example k-fold cross-validation. Apply formulas to optimize AI model accuracy. Module 4, AI/ML Handbook Synopsis. Video, Synopsis of AI/ML Handbook, Subtitle AI Agent. Objective, comprehensive understanding of AI/ML theoretical concepts. Mentorship activity. Read and summarize AI/ML Handbook chapters. Discuss different AI architectures and frameworks. Develop an AI model based on learned concepts. 3 interactive elements for MENTs. A successful mentorship program should include live Q&A sessions based on each module. Hands-on AI coding exercises using Python. Many projects on AI modeling, example predicting trends, AI-driven analytics. Industry-oriented case studies for real-world applications. Mentor feedback and assessments on AI projects. 4 practical AI projects for MENTs. The dashboard can be extended with project-based learning, such as AI-based student performance prediction, using ISO 21001 guidelines. Decision tree model for risk analysis, similar to the pie chart representation. Regression-based forecasting model, similar to the formula-based AI module. AI-driven business insights visualization, applying handbook concepts. 5 future enhancements to the dashboard. Integrate real-time code examples within videos. Add an AI coding sandbox for MENTs to experiment. Include mentor-guided assignments with feedback. Expand the mentorship network with discussion forums. Final thoughts? This AI modeling mentorship dashboard provides a structured learning path, combining theoretical knowledge, AI formulas, decision-making models, and real-world applications. With additional interactive features, it can be transformed into a fully immersive AI mentorship ecosystem. AI Modeling Mentorship Program, Structured Syllabus and Hands-on Coding Guide. This AI Modeling Mentorship Program is designed to provide MENTs with structured AI/ML learning, practical applications, and hands-on coding exercises using Python. Syllabus structure. The mentorship program is divided into 5 modules, covering theoretical concepts, real-world case studies, and coding assignments. Module topic: Key learning outcomes. Hands-on coding task. 1. AI in education, ISO 21001, AI-powered learning and forecasting. Understand AI's role in education and student performance prediction. Build a student performance prediction model using Python. Regression. 2. AI-powered data visualization. Decision tree models and AI graphs. Learn AI-driven decision-making and visualization. Implement decision tree models and visualize AI-based insights. 3. AI model formulation and validation. AI algorithms and optimization. Master key AI formulas and validation techniques. Train a classification model with k-fold cross-validation. 4. AI/ML Handbook, Theoretical Concepts. AI Architecture, ML Pipelines. Gain in-depth knowledge of AI/ML frameworks. Build an ML pipeline and apply data pre-processing. 5. AI Project Implementation. End-to-end AI project applying AI concepts to real-world problems. Develop a complete AI model, prediction/forecasting/classification. Hands-on coding guide, Python-based. Each module includes practical Python implementations using libraries like Pandas, scikit-learn, matplotlib, Seaborn, and TensorFlow/PyTorch. Module 1, AI in Education, Student Performance Prediction. Objective, predict student performance using a linear regression model. Dataset, sample dataset with student scores, study hours, and past trends. Steps to implement. 1. Load dataset using Pandas. 2. Visualize trends using Matplotlib. 3. Train regression model using scikit-learn. 4. Make predictions and evaluate performance. Explanation of k-fold cross-validation, exercise. K-fold cross-validation is a technique used to assess the performance of a machine learning model. It is particularly useful when the dataset is small, as it allows the model to be trained and tested on different subsets of the data multiple times. Steps in k-fold cross-validation. 1. Split the data. The dataset is divided into k equally sized subsets, or folds. 2. Training and validation. The model is trained using k1 folds. The remaining 1 fold is used as the validation set. This process is repeated k times, each time using a different fold as the validation set. 3. Compute performance metrics. The accuracy, or another metric, is recorded for each iteration. 4. Final evaluation. The average of all k accuracy scores is calculated to get a more reliable estimate of the model's performance. Why use k-fold cross-validation? It helps in reducing the bias and variance of the model evaluation. It ensures that every data point is used for both training and testing, making it more robust than a single train-test split. It is particularly useful when there is limited data available. K-fold in the provided code. The dataset has 100 samples and 5 features. 5-fold cross-validation, k-fold, n_splits equals 5, is applied. A random forest classifier is trained and evaluated on each. The accuracy scores are plotted using Plotly with a dark theme. The mean accuracy is shown as a red dashed line. This method helps in evaluating the model's generalization ability and detecting overfitting or underfitting issues. Thank you.